to the class of quality assurance, and in this class we are going to discuss another very important topic, that is qualification of the UV spectrophotometer. And this topic is actually in the syllabus of quality assurance, that is the code of this subject is BP606T, and this subject is in B Pharm 6 semester course. And today we are going to discuss another very important topic of quality assurance, and this topic is given in the unit 5 of this quality assurance syllabus. And I am Dr. Alankar Srivastav, Associate Professor from KITE Group of Institution. So, let us proceed towards our topic. So, first of all, what is this UV visible spectrophotometry? So, before we proceed to the qualification of the UV spectrophotometer, you need to understand some very basics about what is UV spectrophotometry and what is the basic principle of working of UV spectrophotometer. So, first of all, UV visible spectrophotometry is a kind of a technique that is basically used to measure light absorbance across the ultraviolet and visible ranges of the electromagnetic spectrum. And when incident light strikes in a matter, you can easily understand there may be three chances. Either the light may absorb, or it may reflect, or there may be a chance that it can be transmitted. Now, the absorbance of the radiation in the UV visible range cause atomic excitation, and because of this atomic excitation, there may be a transition of the molecule from low energy ground state to an excited state. Now, here in this diagram you can easily understand the basic working principle of the UV spectrophotometer. So, there is a light source, here you can see this is a kind of a light source, and this light, when it goes through monochromator. Now, the question arises, what is this monochromator? Monochromator is a kind of a device, or it is a kind of a instrument which is inside the UV spectrophotometer, which allows only a specific wavelength to pass through. Because this light source emits the different types of lights of different wavelength, this monochromator allows the specific wavelength light to pass through, and it basically strikes through to a mirror, and in which it splits into two portions. The first portion of the light goes through the reference solution, and the another portion of the light goes through the test solution, and the amount of light that is absorbed by the reference and test solution, that can be measured by using detector. So, in this way, by comparing the amount of analyte that is present in the reference solution, that is actually the known solution, we can easily measure the amount of analyte that is present in the test solution. So, this is the simple working of the double beam UV spectrophotometer. So, now let us proceed to our core topic, that is the qualification. Now, what is this qualification? Qualification is a kind of a process that ensures that a system specification is appropriate for its use, and that the system performs according to that specification. And in my previous class, I have given the lecture on what is the qualification, what is validation, and what is calibration. So, I strongly recommend to go through those videos also, but here in this case you can easily understand, if you have gone through my previous videos, that the qualification is of 4 different phases, that is design qualification, installation qualification, operational qualification and performance qualification. So, in order to qualify any UV spectrophotometer, these all UV spectrophotometer has to go through all these qualification phases. So, first of all, let us discuss what is design qualification in the case of UV visible spectrophotometer. So, design qualification in this case, it should be performed before the purchase of any new model of UV spectrophotometer. Now, the documents of the design qualification should explain first of all what the user wants the instrument to do. This is the first question that should be answered before the procurement of the UV spectrophotometer. For example, the functions, functional as well as the operational specifications. What should be the functional and operational specification? For example, there are different types of optics. There may be a single beam or there may be a double beam spectrophotometer. What should be the measurable range? Normally, the measurable range of the UV spectrophotometer is in between 190 to 1100 nanometer. But what is the measurable range for my analyte, or suppose if I am the owner of any pharmaceutical company or if I am doing an analysis of any drug, and what is the measurable range for my drug. So, that is the first objective to that should be and that should be taken into consideration before procurement of any UV visible spectrophotometer. Then another thing, what should be the wavelength accuracy? For example, plus minus 0.5 nanometer or even better. The next thing that are few things that should be taken into consideration, that is criteria for the selection of vendor. Then another thing, what is the warranty and the maintenance support that is provided by the company, or from which you want to opt for procurement of the equipment. Then another factor is discount and the cost of annual maintenance contract, that is AMC, after the expiry of the standard warranty. So, these all are the things that should be taken into consideration before the procurement of UV visible spectrophotometer, and the documents about these all things are considered as the design qualification of the UV spectrophotometer. Now, the next phase is the installation qualification. So, what is installation qualification? IQ is the documented collection of activities necessary to establish that an instrument is delivered as designed and specified and is properly installed in the selected environment, and that this environment is suitable for the instrument. And according to USP, the IQ requirements provide the evidence that the hardware and softwares are properly installed in the desired location. So, after the procurement of the instrument, we have to select the location in which the instrument should be installed, and after the selection of the location, the overall the equipment, all the parts of the equipment are properly assembled as well as the software is installed. So, these all things are included in the installation qualification. The proper documentation of these activities are included in the installation qualification. Now, in the next phase of UV spectrophotometers qualification is the operational qualification. So, OQ is the documented collection of activities necessary to demonstrate that an instrument will function according to its operational specification in the selected environment. Now, these all are the tests that are given that are shown here, which are actually performed during the operational qualification of the UV spectrophotometer. So, what are these tests? The first test is the wavelength accuracy, limit of stray light, noise, baseline flatness, control of absorbance, resolution and stability. So, let us discuss all these tests one by one. First test is the wavelength accuracy. So, in the wavelength accuracy, this test is basically performed to understand the deviations of the wavelength reading from the known wavelength of the band. So, in this case what we are doing, we are actually using some specific analytes or the chemicals. For example, usually we are using holmium oxide solution, that is actually the 4% holmium oxide solution in 10% perchloric acid, which is used for the performance of wavelength accuracy test in UV spectrophotometer. The unique property of the holmium oxide solution, that it gives the characteristic peaks at different wavelength, that is 241.1, 249.9, as you can see in this the board also. These are the different wavelengths in which holmium oxide solutions gives the characteristic characteristic peaks. So, if the UV spectrophotometer is working properly, that means the holmium oxide solution which we have run in the UV spectrophotometer, that should give the wavelength which is very close to these values, and that should be that is actually the basis of the performing this test. The acceptance criteria of this test is plus minus 1 nanometer in UV visible range between 200 to 400 nanometer, and plus minus 2 nanometer between 400 to 700 nanometer, and 3 repeated scans of the same peak standard deviation of the mean must not exceed 0.5 nanometer. So, this is the acceptance criteria for this test. Now, the next test is the control of absorbance or the photometric accuracy. Now, for this test actually we are using the potassium dichromate solution, and the dilution of potassium dichromate solution is prepared in 0.005 molar sulfuric acid. And this test is actually performed in the two different ways, for UV visible as well as for visible region. For UV region, if we are performing the analysis in the UV region, we have to use this potassium dichromate solution in a different way, and as well as in the for visible region there is another methodology. So, for UV region, accurately weigh 57.0 to 63 mg of the potassium dichromate was weighed and transferred to the 1000 ml of volumetric flask and dissolved in 0.005 molar sulfuric acid and diluted to the mark with same acid. The absorbance is measured at 235, 257 and 313 nanometer and 350 nanometer using 0.005 molar sulfuric acid as the reference solution. So, this is the basically methodology which we are used to perform for UV visible range. But for visible range, that is above 400 nanometer, similar dilution is prepared in 100 ml volumetric flask rather than using 1000 ml volumetric flask. Now, in this case absorbance is measured at 430 nanometer using 0.005 molar sulfuric acid as reference solution. Now, in the next step is the calculation of A1% 1 centimeter for all wavelengths. So, that is 235 nanometer, 257 nanometer, 330 nanometer, 350 nanometer for UV region and 430 nanometer as we have already discussed for visible range. So, the acceptance criteria as you can see in this board also, that acceptance criteria of these all are the wavelengths, different wavelengths, and these all are the, this is the A1% value and this is the maximum tolerance value. So, if the UV spectrophotometer is showing all the figures within this limit, that means there will be no question about the photometric accuracy of any UV spectrophotometer. So, this is the second test, and the third test in the operational qualification is the limit of stray light. Now, you can easily understand if there is a poor designing of any UV spectrophotometer, or there may be a faulty monochromator, or there may be a because of the operator use. that is a casual use of the operator, there may be a chance that stray light may also came inside the UV spectrophotometer, which may be detected by the detector. This problem may also be arises because of the age of optics and because of the degradation of these optical instruments that are inside this UV spectrophotometer. Now, what will happen if there is a presence of a stray light? There may be a chance that the higher absorbances ranges, that is the above 1 absorbances, are more susceptible, and for the range of 300 to 350 nanometer, aqueous sodium nitride 50 gram per liter is actually scanned to understand the amount of stray light that is detecting by the detector of the UV spectrophotometer. So, in this case, the acceptance criteria is the absorbance value should be greater than 2, or the transmittance of the solution in a 1 centimeter cell should be less than 0.01. So, if there is a if we are if the UV spectrophotometer is showing the limit within these values, that means there is a very limited presence of the stray light, or there is a no stray light present in the whatever be the light that is whatever be the light that is detected by the detector. So, there may be the UV spectrophotometer passes the test. And the fourth test is the resolution. Now, insufficient resolution in any spectrophotometer may lose some features of the fine spectrum or unable to show the differences of the absorbance values between two close wavelengths. The measure of the ratio of the absorbances of a 0.02% volume by volume solution of toluene in hexane at the maximum and minimum at about 269 and 266 nanometer respectively, using hexane as the reference solution. So, what is the acceptance criteria in this case? The ratio of absorbance at lambda max of 269 nanometer and the absorbance at lambda minima of the 266 nanometer should not be less than 1.3. So, now you can easily understand there we are actually using here a ratio of the some specific ratio of the toluene in hexane, and what is happening here, we are basically getting a graph like this, and this graph is like this. This is the actually minima of 266 nanometer, and this is the maxima which is at 269 nanometer. So, if any UV spectrophotometer is capable enough to show the differences between these two wavelengths, because these two wavelengths are very close, that means there is a no problem in the resolution of any analytes. So, this is the another test that we are performing for in the operational qualification of the UV spectrophotometer. So, let us proceed to the next step. The next test is the noise. The noise originating from the light source and the electronic systems in a UV spectrophotometer and affects the measurement of the absorbance in both lower as well as higher wavelengths. Now, to estimate the noise of the spectrophotometer, air is scanned, that means there is no sample. Air is basically scanned for 10 minutes in absorption mode, and the root mean square RMS is calculated and recorded at 500 nanometer. The acceptance criteria is the root mean square noise should typically be less than 0.001 AU. So, if the any UV spectrophotometer is showing the noise above this value, that means there is a noise, that means the optics arrangement should be rearranged. So, this is the another test. Then fourth thing is the stability. The measurement of the instrument should be stable enough, and this thing is also fit for the UV spectrophotometer also. So, the changes in the component and age are the major factors that making the instability of the response by UV spectrophotometer, resulting errors in readings. The error caused by these factor may be positive or negative, but positive more than actual observed, negative less than actual response observed. Mostly we are the errors are positive. The rare cases in which they are the stability issues are negative is there. Now, for checking the stability, the air is again scanned for 60 minutes in the absorbance mode at particular wavelength, generally 340 nanometer, and deflections in the absorbances are recorded. So, in this case also the acceptance criteria, the deflections should be less than 0.002 AU per hour. So, this is the acceptance criteria for stability. The next test is the baseline flatness. The baseline is used to nullify the effect of environment in measurement by removing background noise to get the true absorbance profile of analyte. In double beam UV spectrophotometer, baseline correction is usually performed by keeping solvent in one cuvette and test solution in another. This will automatically correct the baseline and subtract the background noise by solvent. Now, this test is performed by scanning air in the absorbance band in UV region, and the highest and lowest deflections in the absorbance units are recorded. The acceptance criteria in this case is typically, it should be typically less than 0.01 AU, that is absorbance unit. Next test is in the operational qualification is linearity. Ideally, the absorbance should increase with the increase in the concentration of analyte in solution. You can easily understand, if the concentration of the analyte is more, that means the absorbance also should be more. So, for this, the various dilutions of the potassium dichromate that are prepared in the range from 20, 40, 60, 80 and 100 mg per liter in 0.05 molar sulfuric acid, scanned by keeping 0.05 molar sulfuric acid in reference cuvette. The calibration curve is prepared by measuring absorbance of each solution and correlation coefficient is calculated. Now, the acceptance criteria in this case, these correlation coefficient, that is the R value, this R value should be equals to or greater than 0.999. Now, the last phase of the qualification of the UV visible spectrophotometer is performance qualification. The performance of instrument may change gradually over time because of normal wear of parts, failure or charge of its components. The purpose of the PQ is to provide evidence that instrument is fit for its routine use. Now, generally performance of UV spectrophotometer measurements are performed under identical conditions for the test specimen and the reference substance, for example, UV reference standard. So, what we are doing basically in the performance qualification, we are actually here in this case we are actually judging the performance of our instrument in the actual running condition. So, if there are deflections in this case, that means our UV spectrophotometer is not performing well, and again we have to qualify the UV spectrophotometer. So, this is basically the performance qualification. So, in this way, this is all about the qualification of UV spectrophotometer, and in this video we have learned about the different phases of the qualification of UV visible spectrophotometer. First of all, we have started with the design qualification, then operational qualification, installation qualification, then operational qualification, and lastly performance qualification. So, I hope you have liked this video. So, thank you friends, thank you.